Today, let us learn about atomic structure. Atomic structure is about atoms. Atoms consist of positive charges and negative charges. Positive charges are called protons and negative charges are called electrons. In addition to that, in the nucleus, you will find neutrons which do not have charge. So, in an atom, there is a nucleus which consists of positive protons and neutral neutrons, and electrons revolve around the nucleus. Just like the planets revolve around the sun. The same way, the electrons revolve around the nucleus. Now, let us talk about a particular atom, sodium. Sodium has atomic number 11. Atomic number means number of protons, and mass number is number of protons plus number of neutrons. Now, let us talk about number of protons. 11 protons are there, and you will find that 11 electrons will be there. The number of positive charges is equal to number of negative charges. That is why atom as a whole is neutral. Atom as a whole is neutral. Now let us take another example of chlorine. Chlorine has 17 protons, which means it has 17 electrons. That means the atom is electrically neutral. Now what I want to do is, I wanted to make the atom into a charged particle. So how can I charge it? When I charge it, the atom will become an ion. Let me take the sodium. Sodium 281. This is the structure. Now, in the nucleus, 11 protons and 12 neutrons are there. Fine. Now, how am I arranging them in the shell? In the first shell, there are 2 electrons. So, 2 electrons, 1 and 2. Second shell can occupy 8 electrons. So, I have taken 8 electrons here. 1, 2, 3, 4, 5, 6, 7 and 8. Why this? This follows something called octet rule. In the octet rule, you'll find that the electrons which are the second shell onwards can only be 8 electrons, and the first shell can have only 2 electrons. Now, only one is left out, and that comes in the next shell, and this is the last electron. The outermost electron in chemistry is called valence electron, and in physics it is called a free electron. Now let us take for example chlorine. It has 17 protons, 18 neutrons, 17 plus 18 is 35, its mass number is 35. 2 electrons, 8 electrons, octet rule, and left out is 7 electrons are there in the outermost shell. So I have taken 1, 2, 3, 4, 5, 6, 7 electrons. Now tell me, in this chlorine, how many electrons can fit in here in the outermost shell? According to octet rule, 8 electrons. So there is a vacancy of 1 electron. So when you bring sodium and chlorine close to each other, what will happen? The sodium will give its 1 electron to the chlorine. When it gives 1 electron, you will find that, let me remove this shell now totally. It has given 1 electron. Okay, so number of protons is 11. Now number of electrons is only 10. Okay, so number of protons are more than number of electrons. So sodium is a positive ion, Na plus. It is a positive ion. Atom becomes an ion because it has given 1 electron. Right? It can be any number, but here it is 1 electron. Now, to who does it give? it gave to chlorine. Now chlorine has got this and it has become 1 electron, it got excess, right? In the case of chlorine, there are 17 protons are there and 18 electrons are there. Okay, now the number of protons is less than electron and chlorine becomes Cl minus, a negative ion. So sodium and chlorine together they form Na plus and Cl minus and it will give you sodium chloride. Sodium chloride is nothing but common salt which we take it, namak. That is called sodium chloride. That is positive and negative ions come together, form a bonding, right? And they lose and one gain and it follows the rule. And the whole process is called electrification. A bit in physics, I will tell you. It was Thales of Miletus in 625 BC. When he was walking in the seashore, he found a substance called amber. Like this, imagine. It's a resinous substance, which is a sticky substance, and he found that it is attracting dry leaves. So he thought it has certain property, but it was forgotten. He's a Greek philosopher, right? And then it was Benjamin Franklin who made further study. What is the basic principle? You can take a simple example. Take a glass rod. Imagine this is the glass rod, and take a silk cloth. Fine, and you rub it, right? And one will lose, the other will gain. One loses electron, other gains electron. One becomes positive, another becomes negative. And the second example you can take here is a woolen cloth with ebonite or plastic. You will find that the reverse process will take place, and the whole thing comes under electrostatics. Fine. And Benjamin Franklin accidentally gave the positive charge, which he called this as vitreous, and negative as resinous. Vitreous positive and resinous negative, and electrons he said are negative and protons is positive. There is nothing negative about electrons. Electrons play a very significant role in electronics and everywhere, though it is negative. And that is the whole history of electrostatics, about structure of atom and everything. Thank you so much.